Go.
Good morning, ladies and gentlemen. Many of you guys don't know this, but Miss Moore is getting in touch with her inner yogi. And what that means is I'm able to compartmentalize how I experience pain.
Yeah.
And so let's go ahead and start a demonstration here. I'm gonna go ahead and light this candle on the front. It smells good. Okay. Very steadily. And I've been practicing this with my yoga teacher. Oh, man. Candle blew out. Alright. So here we go. I'm gonna go ahead and remove the binder. And okay, so I've been practicing this with my yoga teacher. I'm gonna go ahead and
Careful.
It's getting hot. Okay, pain is not real. Pain is not real. And what is the trick to dealing with your pain like this? You don't light the candle.
Whoa!
Did I set it down the right spot?
Good morning and happy Day of the Teacher at Golden Valley High School. Teachers,
Thank you.
Day of the
you're
teacher.
out there, come on by the library workroom and have a bagel time bagel, coffee and juice.
Whoop-de frickin' do.
Bagel
Now you
time?
can check to see if it's in the right space.
Yeah. Oh, okay, so let's go ahead and move this a little bit here. And there we go. Okay, so it should be in the right spot now, right there. Okay, so what's going on here? We're gonna talk about it today. The candle is not actually lit in the back. What is going on? That is our goal today. Yes, Ms. Moore is working on her inner yogi. That part was real. Okay, so if you can see an object, light is coming from it toward your eye.
It's a basic fundamental thing. If you can see something, light is coming into your eye from that thing.
Yeah. It is either luminous or illuminated and light is reflecting. So what are some examples of this?
Now, luminous would be the candle.
Candle, okay, and then light coming towards your eye,
You got
that I'm
the light
experiencing
bulbs
from
up
here,
here.
right?
You got that. Oh, that screen right there.
And it's illuminating me. So, and that's a good example.
That's luminous.
The projector, the actual light in the projector is luminous.
Yeah.
It's the light, and the screen is being illuminated, right?
Yeah.
Reflecting the light.
Yep.
Oh yeah, we had another one. The sun, right? The sun
Yeah.
is big time luminous, and it illuminates many, many things, you and me being one of them, but the moon is also illuminated.
The moon is illuminated. The moon itself doesn't shine. It's not a source of light. It's the sunlight shining off, bouncing off of
I
it.
hope you know that. If you don't know that, then, well, now you do. Okay, so an image is what you see.
Okay, we're making some fundamental playas here. The object is a source of light that comes to your eye, and an image is what you see. So object and image are going to be important to us.
A plane mirror is a smooth, flat surface that produces a regular reflection. And this acts like a plane mirror.
Yeah, it's a
Right.
two-dimensional surface. We wish it were flatter than it is, but we would do with what we got.
You know, and this also reminds me of, remember the road when we said that there was water on it? It acts like a plane mirror.
Right, as opposed to the rough road that'll give you strawberries if you fall off your bike onto it.
Yeah, that's not fun. The image produced by a plane mirror is not real. It is not real. It is located behind the mirror. So was I actually burning myself over here when I put my hand here? No, like I'm not, right? And why is that? Is because this image is not real.
Yep, you saw something there. In fact, light the candle again in the front.
Yeah, so it's not real. And where is this image located? Like we said, it's located.
So we have a luminous object.
What does it look like in the video? Oh,
It
cool.
looks good. We have a luminous object in the candle, and that you can tell that it's not exactly in the right place in the back.
Yeah, it's not real. If it was, I would be burning myself, right?
So the image is in the back, because you see that image right there? That's not the candle. That's the object that is the image that you're seeing, and it's bouncing off the mirror,
and
the surface.
and into your eye.
Yeah.
Right? Okay.
So, but it's not real, and it's located behind the mirror.
What do we? There's a name for these things. We call them, if it's not real, we call it. It's called a virtual image because the light is not coming from the location of the image. Rather, it's bouncing off the
It ain't
plane
real.
of your eye.
It ain't real. See?
Yeah, it's not real. It's virtual. It's behind that plane mirror.
Yeah.
Okay. All right. Okay, for a plane mirror, the image is located where the light rays appear to converge. Oh, wait, we didn't look at that page yet. Page 14. 418. Ah. Okay, so I think maybe this one right here, Boykin?
That's the image. Here's a guy standing in front of the mirror.
Yeah.
And light from his feet bounce off the mirror into his eye. We think that light travels in a straight line, so we see the image back here. From the top of his head, light bounces off the mirror, obeys the law of reflection, and into his eye. If you draw a straight line from his eye to where it hits the mirror, that's the top of his head. Same thing with his hand.
Okay, so that's what we mean when we say light is bouncing off the plane mirror into our eye.
Yep.
Right? And then that's what we see the image behind it. It's virtual. It's not real, but we see it there. Like,
Understand, this violates what you think. I mean, when was the first time you saw yourself in the mirror?
Yeah.
You know, your mother picking you up and put you in front of the mirror. Look at that cute little baby. Look at those chubby cheeks. And you know, I mean, you've been looking in the mirror every day of your life, and you have your own idea of what it is that you're seeing. And what you're seeing is an image of you. It's not you. You're not in the mirror.
Even though it looks like you are, right?
Yeah, you're not in the mirror. You're behind the mirror. So think about that for a minute.
Yeah, behind the mirror. That is big. And the image is located where those rays converge. We're going to practice that in a little bit. So, measured from the plane of the mirror, the distance of the object is equal to the distance of the image. So what does that mean?
So one of the things we want to try to do is you can see where the mirror is, and that distance has to be the same. Okay, and you can see here it's if you take all you got to do is take a look. It's not exactly in the right spot.
Oh,
you
yeah,
need to
let's
move
adjust it
that
here.
front candle.
Yeah, yeah. So we'll move it a little bit forward. Right there, right?
Boom.
Boom.
Now the distance to the image is the same as the distance to that candle that's not lit.
And notice that you can see this, you can see this on all sides. The law of reflection obeys all the angles here.
Yeah, it works up here.
Yeah.
And over here and down here and way over there.
And again, what's happening for us right here is light is coming off of here, bouncing up here into my eye.
Yep.
Right? And I'm seeing that image back there.
Yep.
Okay, very cool. Law of reflection is the bomb.com. but also, I mean, you know, this is important. The distance of the object and the distance of the image are equal when measured from the plane of the mirror. That's what we're getting at right there.
Yep.
Okay. And it's time for the mirror lab.
Oops. Just sprayed the wax all over the table.
We'll have to wipe that off.
Clever Mr. Boykin.
I guess I'll leave the light on for now, right? While we go ahead and explain it. Let me get my marker.
Well, you're going to need a pencil too.
Pencil and marker. Right. So, so mirror on the wall. So we see light traveling in straight lines. Yes, the image we see when we look in a plane mirror is not real and is located behind the mirror. This activity will show you how this works. Okay, so we've got our lamp here. We've got our mirror. We're gonna draw a line on here. Shall I do that right now? Baby?
Yeah.
I can just draw it anywhere, right?
Yeah, that's a good spot. And it's got to be long. You got to make it long, like from one end of the paper. There you go.
Speaking from experience, there it is. Okay. All right. So draw a straight line on the back of this paper, like in the picture above. Hamburger. Place the experimental lamp on the paper with a double slit over the straight rectangular opening, so you can see we've got our double slit right there. Yeah. Place the plane mirror on the block exactly on the line like the picture above. Okay. So here's our plane mirror. So cute. Okay, and we're gonna place it exactly on the line. Boom. You might have to move it around, but we'll start there. Okay, turn on the light. Now, one thing that I forgot to mention is, Boykin, what'd you say about the image being back here?
Well, the light bulb is the source, and the light bulb is right,
yes.
right there.
Okay, so turn on the light. Notice the beams diverge.
It is they
spread apart
And you
right
can see
here.
right here it's going under the mirror.
Yeah. Oh, yeah. A
And
little
they
bit of
get
under.
farther apart.
But you can see how they're kind of diverging right here, right?
Yeah. Now the question is, how can we show where these lines were when we turn the light off?
Okay. Well, we can just mark it with our pencil.
Yep, little
Right.
dots.
Okay. So
2 dots per light ray.
let's do it. So place dots in the center of each beam, incident and reflected, to locate where the beam was after you turn it off. So again, I want to make these as small as possible. There's one. There's the second one. Okay, and then
She's making little tiny dots and then putting a circle around them so she can find them later.
yeah. I think I forgot this one. Oh, it's
You need 2 more
oh, yeah.
near the
Oh, right
mirror.
here and here, yeah. Yeah, right there.
All right.
Boom, boom, boom.
Now
okay.
what?
Now what? Okay, so remove everything. Got it. From the paper and draw dotted lines to extend the reflected rays behind the mirror. Okay.
So we can take this off. We can take. Okay, which which dots are which?
Oh, right here and right here. Oh.
Yeah, this is incoming. That's outgoing.
Yeah, yeah.
This is incoming. That's outgoing.
Yeah. Okay. Okay. So let me go ahead and.
You can take the
Move
mirror.
this right here. Okay, so I'm gonna make sure it's nice and long back here.
And what we're going to have is something that looks like this when we're done.
Oh yeah, so I don't want to extend too. I don't want to extend on this one right
That
here.
one you don't have to extend.
Yeah. So we have the incoming rays. Miss Moore, can you read?
Well, yeah, if you can read, you just need to look at it first.
There we go, like that. Now those look like they're converging.
Well, they're
Oh, it's because this one right here.
yeah.
You see how I caught my mistake, you guys? I'm like, that's not right.
Yeah, they diverge. They get farther apart as they go
So
along. So
it's-
she connected this dot should go to that dot.
Exactly. These things happen.
And life goes on. No harm, no foul, no bruises. We're not bleeding.
Yeah. All right, so then from here,
Now, what I would do is I would extend these 2 lines
A little
back
bit
in
further?
this
That's a
direction,
good
back,
idea.
you know, as far as you can.
okay.
And they should cross where the light bulb was inside the lamp house, right?
Oh yeah, okay, that makes sense.
Because that's the source of light.
There we go, right there,
And they cross.
right there. So this is the distance.
Yeah, make a little dot there.
Yeah, right,
Yeah.
right there.
So now that's
This is
the
object.
inside the light box. That's where the light bulb was, the source of
Yeah,
light.
so that's
Now,
our object.
now we got to do these guys.
Okay. So now, oh no, I want to go this way. Let me go that way. Is that light up there? A little bumpy there. Okay.
Now, notice we're drawing lines behind the mirror. Now, the light didn't actually go behind the mirror. This will allow us to locate where the image is, because these light rays diverge. They will never come together. They only come together right there.
So that would be where the image, that's where our image would be.
Yeah.
Okay. Now, does that look perfect? Definitely not.
Now, let me go get a protractor. And what you want to do is put the protractor like this, and then with your mirror like with your line like this, make it perpendicular, because we want to go from the normal, and then draw a line from the converging point to that plane where the mirror was.
Yeah. I guess it's a lot harder than it looks. Okay, so right there. Bada boom. Right
And
there.
do the same for the other one, and you can see
There's more is a little off here.
This obeys the law of Gigo: garbage in, garbage out.
Yeah. It's a good one. Gigo. Okay, so we're right there. Okay.
Now let's measure these two distance.
Yeah.
This will be the distance to the object. The object was here,
Okay.
and the centimeters is fine.
So we'll call it 19.12. We'll call it 19.2.
19.2 centimeters.
I said 19.C. 19.2 centimeters.
And then measure this. That'll be the distance to the image.
Yeah. We're a little off there. So 13.7.
13.7. So now, that's a significant.
Yeah.
Why don't they match? Well, we've got to hit the dots exactly on the right thing, and then we got to draw the line all the way back here. And any variation in this at all is going to change the location of this. Same thing over here. Look how short these lines are, and we're extending them all. So any error that's in here is going to be magnified right there.
So what should we have seen here?
Well, what we should have seen is this be right here.
They should be in the same location, and they should be right across from each other, and they should also be equal distance from the plane mirror.
But in this world, ain't nothing perfect.
It is what it is. Okay.
And so, but the main thing is this allows us to locate where the image should be using, this is called a ray model, well, ray model diagram, using light rays traveling in straight lines.
So even though our data isn't great, we're still going to record it. 19.2 here, and then 13.7.
Simple, yes?
Okay, that is what it is. All right, and we're done.